Hello everybody, and thank you for joining me. In this video, I'm going to show you how to program the motors on the STEMBoT 2. First things first, make sure that your STEMBoT 2 is plugged into your computer and open up your favorite serial programming terminal. I, as always, will be using PuTTY. In addition, make sure that your STEMBoT is propped up so that the wheels attached to your motors are not touching your desk, because once you start programming it, you don't want it to accidentally drive off and fall onto the floor. In addition, you'll want to make sure that the power switch is turned to the on position, and you can tell on the PCB which is on and off. This way it can actually use the battery for the motors instead of just the USB power supply, which can't provide enough current to run the motors. So make sure that your STEMBoT 2 is fully charged when you do this. When you open up PuTTY, you should see a screen like this. Go ahead and hit Control-C to exit the main program. The classes and the functions that we want to use are in the SB module. So let's take a look in there by typing in dir and SB in parentheses, and that will show you all of the classes and functions that are available to us. These include things like the LCD, the radio, servos, and the motors, as well as some conversions that we're going to find helpful later on. For now, since we're using the motors, we'll want to import them from the SB module. So I'm going to type in from SB import motor and make sure that motor is capitalized. Once we've imported the motor class, we can go ahead and assign some variables to the two motors. So I'm going to type M1 is equal to motor 1 and M2 is equal to motor 2. Whether a motor is on the left or right side is dependent on your configuration, but the standard configuration has M1 on the right side and M2 on the left side. To start using the motors, we will have to wake them up from their sleep mode by using the sleep function. We will set them to false. Make sure false is capitalized when you do this. Getting the motors to move is as easy as using the distance method of the motor class. This method accepts 4 parameters. The first one is the number of steps you want it to move. There are 200 steps per revolution of the wheel. There are easier ways of going about this than thinking of steps, and I will cover that here momentarily. The second parameter is the speed at which you want the wheel to rotate. This accepts a number between 50 and 500, and either positive or negative. The sign determines whether the wheel rotates forwards or backwards. Using the STEMBoT 2 standard configuration, negative means it's moving forward. 100 is usually a pretty good speed, but if you want it to go faster, you can go higher than that, up to 500. The third parameter is the acceleration, or the time it will take for the wheel to get up to its highest speed. Usually you don't need to put anything other than 10 here, but you can play around with it if you want to. The final parameter is for what's called blocking, and in programming this will stop the next lines of code from executing wherever a block is found. In general, you can set this to false. But if you have a lot of lines of code where the distance function occurs one right after the other, you might want to think of using the blocking function to make sure that one distance function completes before the next one is executed. If you don't want to use steps, we can use some of the conversions provided to us by the SB module. To do that, I will import from SB inches to steps. And what this does is it automatically converts the number of inches that you want into a certain number of steps. So for instance, if we just use the function on its own, for 12 inches, there are 228 steps, so a hair over one full revolution. If we want to use this with the distance function, we can just go ahead and substitute the number of steps with this function. To make things even easier, we can assign this value to a new variable. So I'll go ahead and create a new variable called in12, and give it that number. And if we type in 12, it should show 228. So now we can just use this variable in the distance function instead of having to type out the entire inches to steps every single time. For this exercise, we will create a program that will move the STEMBoT 2 forward 12 inches whenever you press the A button. To start, import the capital switch from the switch module. This will allow us to use the buttons on the STEMBoT 2. We'll go ahead and assign a variable, A, and remember that because the button isn't pressed, it will return false. If it is pressed, it will return true. Next, we'll build a function that will move the STEMBoT 2 forward 12 inches. Start with the keyword def, and then the name of your function. I will call it move12, followed by parentheses and a colon. And then I will use the distance functions with our in12 variable, and I'll make sure to do this for both motors this time. Finally, I'm going to make an infinite loop that will test the value of the button so that whenever it's pressed, it will execute the move12 function. To do this, we'll start off with a while loop, and then if the value is true, as in if the button is being pressed, we'll go ahead and use the move12 function. Otherwise, if you don't want to do anything, you can just use the keyword pass and it will do nothing. So now it's running this infinite while loop, and if you press your A button, it will move forward 12 inches. You can go ahead and unplug it. Make sure that it's still on, the battery is still powering the motors. Unplug it, put it on the ground, and press the A button, and you should see your STEMBoT move forward a foot. And now you know how to program the motors on the STEMBoT 2. Thank you for watching.